Yeah, hi everyone. Good evening. I think I'm audible to all of you guys. Can you please confirm in the chat? Yeah, and welcome guys. Welcome to our Computer Vision for Developers series, and today is day 13. And extremely sorry for yesterday, guys. Yesterday it was raining here, and because of that, there were some power cut issue. That's why I couldn't able to continue the session. Okay, so today I will try to continue the same session again with the same energy. Okay, then same way. Okay, we usually conduct the session in our channel, and today we'll be learning one amazing topic called image classification with the help of PyTorch. Because many people were talking about, sir, we are learning about the TensorFlow implementation. Now what about the PyTorch? Okay, so what would be the difference between PyTorch and TensorFlow implementation? So today I'm going to show you. Okay. Yep. Yeah, no coder. Walaikum salam. I hope you are doing well. And thanks for joining, guys. Thanks for joining. All right. So before starting, guys, please try to hit the like. Hit the like so that we can start. And one thing, guys, if you see, some of the person are asking me, sir, when is the live session, let's say, scheduled date? Let's say the computer vision playlist is going on. Now, so which day, which time actually you are conducting the session? So for this, you can check the live section. If you click the live section, now, so here you will see the schedule option. If any upcoming schedules are coming, you will be able to see that. And otherwise, you can also join my Telegram group. So in the description, guys, I have added one link, join my Telegram group. Okay, so this is my Telegram group link. So you can join here. The group name is DSwithBappy AI community. Okay. So only 20 member join, guys. I don't know why, because I can see there are so many people they are watching the content. So all of or you can join here and you can discuss about any kinds of problem. Even you can connect me here also personally if you are facing any kinds of issue. Definitely I'll try to help you with that. Okay, so this is the group, guys, I have created for you. So you can join here, and those who are let's say you don't have the Telegram, you can't access the Telegram, for them I will also create a Discord group or WhatsApp group. Okay. Yeah, so first of all, try to join in the Telegram group. So for them also I'll try to create a new group. Okay. So I want you guys, all of you, just try to join in this group. Okay, because here I'm going to give you all the announcement. So this would be easy for me to give the announcement if I'm conducting any kinds of session or not, because for some reason actually I may not conduct the session. Let's say yesterday there was an issue, right? So I had to post over my YouTube channel. So instead of that, if you join here, so I can give my announcement. So that would be fine for everyone, I think, right? So please try to join in the group. Link is mentioned in the description. In the same description, just try to check and join in the group, guys, all of you. Yeah, so today there is nothing theory, guys, everything is practical, because so far whatever we have learned, the image classification we did with the help of TensorFlow. Now we have to do with the help of this PyTorch. Okay, so I think you know the PyTorch, guys, yes or no? PyTorch is a library. Okay, it's a deep learning library like your TensorFlow. It is implemented by Meta, Facebook, and TensorFlow implemented by Google. And PyTorch, it is a little bit low level. Okay, if you see the PyTorch syntax, it is a little bit low level. Okay, and if you see the TensorFlow keras, it is high level. And PyTorch is most used in the research development, because in the research they need more customization. Okay, and more customization can be done with the help of PyTorch. But in TensorFlow keras, they provide the high level API, so there lots of customization options are not available. Okay, so if you want to customize that, you have to use the TensorFlow, like let's say low level TensorFlow that time. And low level understanding low level TensorFlow is little bit hard for you. Okay, so that's why people are going with the PyTorch implementation if they're going to any kinds of research field. So as a developer, either you can start with PyTorch development, either you can start with TensorFlow development. Okay, it's up to you. But see, till image classification, I will suggest go with TensorFlow implementation because it would be easy for you. Because there everything is high level. You don't need to write so much code for that, okay? But going forward, whenever we'll do the object detection, then object segmentation, then object tracking, so there mostly we'll be using PyTorch. Because all the library will be getting, now let's say detectron 2, YOLO, so everything has implemented with the PyTorch, not TensorFlow, okay? Yeah, so till object classification, I'll suggest go with the TensorFlow Keras. Okay, why? Because today I'm going to show you one implementation, so after that you can compare. Okay, you can compare which one is the easy, our previous one or this one. Okay, so first of all let's implement, then you can decide, okay, which one you can use. So to install, guys, PyTorch, what you can do, you can click on get started, and they have given the commands. Okay, so you can see, you can select the distribution, so PyTorch, so stable version 2.7.0, and if you want to install the nightly version, so you can also select this one, but we usually install the stable version. And you can select your operating system, whether you are using Windows, Mac, or let's say Linux. Let's say I'm using Windows, I will select this one. Then package, okay, whether you want to install with the pip package manager, then libtorch or source, you can select this one. And language, you are working with C++, Java, or Python. Okay, I'm working with Python, and you can check your CUDA. So this is for the local installation, guys. Okay, so if you are having local GPU in your system, okay, that time you can select the CUDA version. How to get the CUDA version? For this, just try to open up your command prompt. Try to open up your command prompt, and in the command prompt just write NVIDIA, okay, hyphen SMI. So if you execute, so here you will be able to see your CUDA version, guys. You can see this is the CUDA version, and this is my driver version, and this GPU actually I'm using NVIDIA GeForce RTX 3060. Okay, now you can see CUDA version, for me it is 12.6. okay, so that's why you have to select the 12.6 here. Okay, and if you have already let's say yeah, this one 11.8, that time you can select 11.8. If you're having 12.8, you can select 12.8. okay, and those who want to install only on the CPU, you can select the CPU for that. So if you select everything now, so this is the final command. Now let's try to copy the command and execute from your terminal. It will install PyTorch in your system, but make sure you have GPU configured. Okay, you have GPU configured. And how to configure the GPU, guys? So for this I created one tutorial in my channel. If you search here, let's say GPU, if you search GPU here, so this is the tutorial, guys, how to set up NVIDIA GPU for deep learning, install CUDA and toolkit CUDNN. So just try to go ahead with this video, and this is the most popular video on my channel, guys. You can see it got like so many views. So those who are using local GPU, guys, and if you want to set up the local GPU, I will suggest go with this video. First of all, try to set up the GPU, then try to install the PyTorch. Okay, if you want to execute in the local machine. Okay, but I know that many people, they don't have the GPU, so what I will do, I'll just try to use the Colab, Google Colab, because in Colab we'll be getting a free GPU. Okay, so let's create a new notebook, and in Colab, guys, you don't need to install the PyTorch. PyTorch is by default installed in Google Colab. You don't need to install it. But those are using Windows, okay, sorry, those are using local system, and if you want to install PyTorch, so you have to follow this particular command. And before that, try to go with this video. So this video will give you the entire understanding how we can set up the GPU in our system. That's it. See, there would be like so many video, because we'll be covering each and everything inside computer vision. Okay, so next class onward, I will start the object detection. So object detection will take some session. Okay, I'll be taking couple of sessions. Then image segmentation, object tracking. Then we have OCR. Then we have GANs. Okay, then we have vision transformer. So I think so many topics are left. So I think 30 class. Okay, I think around 30 class I'll be taking. Okay, in this playlist. Shubhashish. Like, see how many classes required, I'll try to take. No need to worry. Okay, until I complete everything, I'll keep on conducting the session. Okay, so now let's rename this notebook. So I'm going to name it as image classification using PyTorch. And you have to select the GPU, guys. Click on runtime, change runtime type T4 GPU. This is the free one, and I'll try to save it, then connect the notebook. And today the data, guys, I'm going to use. So this is the data, guys. I will share this data in my Google Drive. This data I already downloaded from Kaggle. You can see. See, flower classification data. Okay. So today we'll try to make a flower classification model that will classify two kinds of flower. One is daisy and this is dandelion. Okay. Now let me show you the data, how this data will look like. So here is the data, flower classification. And this is the folder structure, guys. I think you already know the folder structure, how to create the folder structure. Okay. Now let's see if I go to the train. Now see, we are having two kinds of flower. One is dandelion, another is daisy. Now if you see the dandelion, so this is the dandelion flower, guys. Okay. You can see this is the dandelion flower. And here, how many images we are having? We are having 3730 images we are having for the training. Okay. Then in the daisy image, we are also having the daisy category. You can see this is the daisy image. Okay. Daisy image. And how many category we are having? Sorry, how many images we are having? 2645. Okay. Similar wise, I also kept in the training, testing, and I also kept in the validation. Okay. So we'll be using training and validation for the training purpose. We'll try to train the model on the training, and we'll try to validate the data on the validate the model on top of the validation. And after that, once my model got trained, we'll try to test the model on top of the test data. This is the idea. Okay. So this data I'm going to share, guys. This data is available in my Google Drive link. So let me add the link. So here I'm going to add the data link, guys. Data link. So from here you can download. I'll share the notebook. Okay. In the same resources section I have. So first of all, you have to import some necessary library. So let's import. So these are the library are required, guys. Okay. So here you can see, guys, I'm importing Torch. Torch means we are importing PyTorch. Okay. Then from PyTorch we are importing neural networks. Then we are also importing optimizer. It is available inside optim class. Okay. We are importing optimizers. Then if you want to work with the computer vision, guys, because PyTorch is having two kinds of let's say library. One is Torch vision and this Torch audio, I think. Let me show you. If you go to the documentation, PyTorch documentation, so it is having Torch vision. Torch vision. What is the ecosystem? To community forum. Okay. Torch neural network function attribute library accelerate CUDA. What is the Torch vision? I think they have upgraded their documentation, but let me find it. See, Torch audio is there. This is another library. And Torch vision, I think it is there. Torch vision. They're also having Torch data, Torch rake, okay, Torch serve. See, Torch vision. Okay. So for computer vision, you will be using Torch vision. And for audio data, you will be using Torch audio. Okay. So here we're working with the computer vision problem statement. We'll be using Torch vision. So from Torch vision, we're importing datasets, transforms, and models. Okay, these are the common import you have to do for all the development. Okay, then operating system we are also importing here. Now let me import all of the package. Now first of all, here we have to upload the data. So let's upload. I'll right click and here is my data, guys. I'll select and upload the data. So this upload will take some time. Let's wait. Okay, almost done. Okay, it is uploaded. Now see, this data is available. Now this is a zip file. I have to unzip the data. So this is the command. So unzip, just copy the path of the data and try to mention it. Now if I execute, it will unzip the entire folder. Okay, complete. Now if I refresh, now see my data is available. Flower classification data, see train, test and validation. Okay, everything is available. And inside that we are having two category like daisy and dandelion. Okay, fine. So let me take some code cell. Now the next system, guys, we have to define the data transformation, augmentation and normalization layer. So let me comment here. See, you have to define data transformation for augmentation and normalization. I think you remember, guys, in TensorFlow also we did the augmentation. Okay, so similar kinds of thing you also have to do in the PyTorch, and this is the code for that. This is the code for that. Data transform. Okay, so here first of all we are transforming the training data and we are also transforming the validation data. Okay, now you can see, guys, transform.compose, and here you are giving some augmentation technique. That means you are giving random resize crop, then random horizontal flip, then you are converting the entire data to tensor, then you are doing the normalization also. Okay, and for validation also you are doing the same thing. You are resizing, you are doing the center cropping. Okay, then you are converting to the tensor, then you are normalizing the layer. Now there are different augmentation techniques are available. You can use any of them. Okay, it's up to you. So for this development I'm using these are the augmentation technique for the transformation purpose. And this object we are creating, guys. Now with this object I'll try to augment out my data. Okay, but before that, first of all I have to load the data. So let's define the dataset directory. So this is my dataset directory. You can see I'll copy, and this is the path of my dataset directory. Okay, now let's try to define. Now we'll try to create a data loader, guys. In PyTorch we create a data loader. See, this is the code for data loader. So here we have written a you can see a dictionary comprehension. Okay, you can see we have written a dictionary comprehension. So here what we are doing, guys, that transformation, that means this object we have created now. So we are calling that one for the training and validation both data set. You can see data transform we are calling, and we are storing the data as a training and validation. Okay, let me show you. So if I uncomment this one, now see, first of all we are creating the training data loader, then we are creating for the validation data loader. Clear? And what is data loader? See, data loader is an object in PyTorch. So it will not load the data in your memory instantly. Instead of that, it will only load the metadata. Okay, this is called metadata. And whenever you will start the training, now that time it will load the data into the memory. Okay, that's how it will also try to save the memory, because if now I'm loading the data in my memory will get full, and whenever I'll try to train the model, it will give me crash. Okay, so that's why we are creating the data loader, and data loader also will help you to load the data as batches. Okay, batch by batch it will try to load the data. Now to create a data loader, guys, first of all we are creating the object. Okay, we are creating the object. You can see first of all we are transforming the data, and this is the metadata I'm getting. Now we'll try to create the data loader object. So see, this is the data loader object. So you can see I'm using torch.utils data loader. Inside that I'm giving my data. Okay, for training and validation both I'm doing, guys. You can see for training and validation both I'm doing, and here you're defining the batch size. Okay, you will be doing the shuffling operation, and number of workers means like it will be let's say executing the data in the multi-thread. Okay, that means it will be utilizing different threads, and it will try to do the job. Okay, parallelly it will try to work. So that's why you can also define the number of workers. So these kinds of customization option is available inside PyTorch, guys. Okay, so that's why it is more popular in the research field. But in Keras, you will not get this kinds of customization option. Now once my data loader is created, I'm checking the data side. What is the data size for my training and what is the data size for my validation? You can see I'm using the length function. Now see if I execute, see for training I have total 6,375 images. For validation I have 364 images. Okay. Now we are going to also save the class name. And how to save the class name, guys? That's how we can save the class name. Image dataset training. If we just write dot classes, it will extract the class name only. Now see, we are having two classes, Daisy and Dandelion. Okay. That means if your model is predicting 0, it's a Daisy. If your model is predicting 1, it's a Dandelion. Okay, this is the order. You can see this is the order of the category. Now we'll try to load a pre-trained model, guys, because we are doing the transfer learning here, and we'll be using ResNet 80 model, guys. This architecture will be using ResNet 18. So this is developed by Microsoft. So see, this is the architecture of that model, ResNet 18. See, you can zoom this architecture, you can understand. Okay, I think this is a little bit blurred. So let's take this high level architecture. See, this is the architecture of ResNet 18, guys. Let's open it in a new tab. See, this is the architecture. So they're using 3x3 filters. Okay, 64 convolution, again 3x3 filters, again 64 convolution. Okay, so that's how they're using multiple convolution. Okay, then after that, in between they're also using average pooling. You can see, you can try to understand the entire architecture. Maybe you can open this one, you'll be able to get the idea. Okay, what kinds of, let's say, kernel size, what kinds of stride size they are using, each and everything they have mentioned here. I think I already showed you how to understand the architecture. Okay, how to understand any kinds of CNN architecture. Maybe you already know that. Okay. So we'll be using this architecture, guys. Okay, so let's try to load the model, and this is a pre-trained model. Okay, I want to load the pre-trained model. The model they have trained on the ImageNet dataset. So see, here we are loading the model.resnet 18, and I'm defining the pre-train. Pre-train means it will try to download the pre-train weights. Okay, now let me download it. Now download is done, and you can see it is a PTH file. Okay, that means this is a PyTorch file, and this file it has downloaded. Now first of all, what I have to do, guys, I have to freeze all the layer, because previously I also showed you we don't train the entire layer. Okay, what we'll do, we'll just try to freeze all the convolutional layer, and we'll also try to train the FC layer. So for this, let's try to do the freeze operation. So this is the freezing operation, guys. First of all, we are checking if it is a FC layer. Okay, if it is a FC layer, try to unfreeze. That means I want to train the FC layer. And if it is a like a convolution layer, try to make it as false. That means I don't want to train this particular layer. Okay, that means I'm freezing the layer. Got it? Now let me execute. So once it is done, we'll try to define the loss function and optimizer. So let's define loss function and optimizer. So here we're using cross entropy loss, and optimizer we're using SGD. That means stochastic gradient descent. Okay, and in PyTorch you have to specify like that model.parameter. Okay, it will take all the parameter and it will try to define the optimizer and learning rate and momentum. Okay, what is learning rate and what is momentum, I think you already know if you have learned SGD optimizer. Okay, so let's define it. Now here you have to define where you want to train the model. You want to train the model on the GPU or you want to train the model on the CPU. So in PyTorch you have to write this particular line, guys. Okay, so device is equal to torch.device CUDA 0. That means you want to utilize the GPU if CUDA is available. That means if your GPU is available in your system, otherwise it will use the CPU. So this particular code will automatically decide whether you are having, okay, whether you are having the CUDA or whether you are having the CPU machine. Okay, you don't need to manually specify that. Just try to execute this line, it will automatically identify. Now see, for me I have the CUDA, so let me show you. So print my device. See, it is using CUDA 0. That means I have the GPU in my system. Okay, and it will load the model in the GPU right now. That means the training will be happening in the GPU instead of in the CPU machine. Now in PyTorch, guys, you have to write a training loop, and this is the training loop. This is the similar as your Python code, guys. You can see manual Python code. So this is the difference between TensorFlow and PyTorch. Hello, Bappy. Will gradual unfreezing of the CNN layer be useful in learning specific patterns and increasing the accuracy? See, most of the time you can unfreeze the layer because you are using the pre-trained architecture, and most of the dataset it can learn by its pre-trained features. But in some cases, if it is not able to learn, that time you can unfreeze and you can also try to train the CNN layer. Okay, it's a completely experiment. Okay, I can't tell it will work fine for your data. Again, it depends upon the data pattern. Okay, so maybe you can do experiment and you can let us know. Now see, guys, this is the difference between your PyTorch and TensorFlow. See, in TensorFlow we don't need to write the training loop manually. Okay, what we do, guys, we just only write, I think you remember, model.fit, and we just try to give the data and execute the code. It will automatically do the training, but here you have to manually write it. Okay, see, this is the from scratch implementation of training loop in PyTorch. So in PyTorch there is nothing like high level function you will be getting. Okay, yeah, seems like you are creating your own library here. Okay, you are just let's say writing the internal component of the library. So that's why I told you now, in PyTorch there are more customization option, but this is not available in the TensorFlow. TensorFlow provides high level API for the developer, so they don't need to worry about the code. Okay, so they will only give the data, use their high level function, train the model, get the model, build the application, that's it. But if you want to do more customization, more resource operation, that time you can go with PyTorch implementation, guys. Okay, because now you can see the entire training loop you have written manually. And previously I also showed you data loader, we created the batch size, then this number of workers. Okay, everything we have defined manually here. See, initially it feels like scary, but again it's a interesting library. Okay, if you understand PyTorch ecosystem. So maybe I can conduct a different let's say session for PyTorch. So there I will try to discuss the basics about the PyTorch. Okay, because this is the specific to our image, let's say computer vision. So that's why I'm not showing you the entire PyTorch demo. I'm only using the computer vision functionality from the PyTorch. Okay, but in my YouTube channel I have the plan. I will try to launch a dedicated Python session, whether it would be a one-shot video or whether it's a live series. Okay, maybe I can come up with. Let's see. Now see, guys, what is happening in the loop? First of all, you are defining the number of epoch you want to train. So here I'm having like 6,000 data, and it will take time, guys. For this I'm going to only train 2 epochs. Okay, do we need to write the whole code, or we can copy? You can copy. See, nobody write the code from scratch. Okay, so because we already have these kinds of code in the documentation, we just try to do the copy paste, that's it. Okay, but you have to understand the mechanism. Okay, how things are working. You have to understand the fundamentals. Let's say if you are getting any kinds of error, so that you can fix that. At least copy pasting code, it's not a like I mean crime. Okay, you can copy paste any kinds of code, but at the end you have to understand whether you are understanding the code or not. Okay, how this code is working. This is the main thing, guys. Okay, nowadays we have ChatGPT also. Easily I can generate this kinds of code. I don't have any issue. Okay, that will make my productivity time very quick. But at the end I have to make sure like I can understand this code, I can customize this code. I'm thinking of a model interpretability approaches of this model focusing on the correct patterns, recognizing an example only one to facial attributes, gender expression and facial. See, for facial data of processing, I'm going to show you another other model. Okay. So for this we won't be using image classification model, Thomas. Okay. For this we have the face embedding model. So this thing I will also try to discuss. No need to worry. Fine. So first of all, we are defining the number of epoch. Then we are writing a for loop. You can see on top of the epoch. That means how many times it will execute? 2 times. Okay. Then here we are having training and validation data. First of all, we are defining the phase. If my phase is training, if user is passing training data, it will try to make my model in the training mode. Okay, model.train. This is called mode, guys. In PyTorch, it will load the model in the training mode. Then what will happen, guys? This will try to do these kinds of work. But if your model is not training, okay, let's say if you are not passing the training, that time it will be load as a eval. Let's say if your dataset is validation, it will load as a evaluation mode. That time it will only do the evaluation. Now here you are defining the losses and running of correctness. Okay. Now here writing the for loop. So this will try to load the data from the data loader. That means input and labels. So input is what? All the image pixels, guys. Okay, all the image pixels. And what is label? Label means all the category. That means whether it's a dandelion or whether it's a daisy. Okay. And what would be the label ID, guys? I think you remember. Label ID would be like that. That means daisy would be assigned as 0. Dandelion would be assigned as 1. Okay. So that's how this will load the label. Now it will also load the data in the device. That means in the CUDA. Then optimizer, it will try to initialize and the 0 grad. That means if any optimizer value is there, it will try to make it 0 because it is doing the training from the very scratch, right? Then you can see my training will start. Model will give the output. Based on that, we are calculating the loss. Then we are doing the back propagation here. Okay. So this thing we have to write manually. See, loss dot backward. Backward means it will do the back propagation. It will do the back propagation. It will do the web upgrade operation based on the loss. Then it will do optimizer dot step. That means again it will go to the another step. Clear? Then once everything is done, we are checking the loss and the correctness. Based on that, we are calculating the epoch loss and epoch accuracy, and we are printing it here. Okay. And once training is complete, I'm printing training is complete right now. Now let me show you. So if I execute, see guys, to understand this code, you should have basic knowledge of on PyTorch. Okay. If you are completely new to the PyTorch, I know that it would be a little bit difficult for you to understand. So for this, no need to worry. I'll come up with a PyTorch series in my channel. Okay. So there I'm going to explain each and everything. But here I'm showing you. Okay. Those who are interested, like how we can use PyTorch for image classification. This is the demo. Now tell me guys, which library is easy to use for image classification? PyTorch or TensorFlow? Tell me. Optimizer step means it will let's say it will go to the next step. Okay, next step. I think you know about the chaining concept, na? Chain rule, Thomas. It will go to the next chain that time. Now see, first training, this is the training loss and this is the accuracy. And this is the validation loss, this is the validation accuracy. Then second epoch, this is the training loss and this is the training accuracy. This is the validation loss and this is the validation accuracy. Okay. And you can see my training is completed. Now that means here if you see my learning is good at the end. Okay. So if you train multiple epoch, definitely your model will learn better. And it will also try to adjust the training accuracy as well as the validation accuracy. Okay. Yeah. Now my model got trained, guys. Now if I want to save the model, so that's how you can save the model. So torch.save, you have to give model state dict. Okay. So you have to write as a state dict and you have to define the model name. So model name is flower classification model.pth. So PyTorch model would be pth format and TensorFlow model would be h5 format. Okay. Now if I execute, my model would be saved right now. If I refresh, now see model is saved. Okay. Now if I want to use this model to classify on my unseen data. Now let me show you how it can be done. So here let me write classification on unseen data. So first of all, let's import some necessary library. So torch vision model transform and image. Then after that we have to load the model. And how to load the model, guys, in PyTorch? See, in TensorFlow it is super easy to load the model. Only you just need to do model.load operation. But in PyTorch, first of all you have to download the original model. Okay, you have to download the original model. Okay, then you have to define the FC layer. Okay, neural network linear model FC in features 1000. Now can you tell me, guys, why I have written 1000? Yeah, training is fast because see, they use other approach to load the data, other approach to train the model. Okay, that's why training is a little bit fast in PyTorch, I can say. Okay, than your TensorFlow, because TensorFlow at the end it's a high level API. Na Keras is at the high level API. That's why. Now can anybody tell me why I have given 1000, guys, in the FC layer? Any idea why 1000? Because this is a pre-trained model. Na this is a pre-trained model, and pre-trained model is having 1000 category, I think, remember, because it has trained with ImageNet dataset. Now I have to change it with my custom layer. Okay, but for that, first of all I have to so here I can comment out adjust to match the original model's output units. Okay, so first of all you have to give the original model output units, then you have to give your custom model output units. Okay, for this load your own model. Now we are loading our own model, guys. You can see model.load state dict torch.load our flower classification model.pth. Okay, then here you have to specify the mode of the model. What you want to do? I want to do evaluation. Okay, on my test data. Then we are creating the new model architecture right now. So here we'll be creating the new model architecture. To create the new model architecture, model.resonate pre-train is equal to true, and whatever classes you are having in the last layer, that means here we are only having two category, that means dandelion and daisy. So now we are specifying two. Okay, now we are specifying two here, guys. Okay, then once everything is done, we'll try to load the model. So for this you have to give this particular code. So it will try to load the model weights. Okay, you can see model weights, it will load. Now if I execute, your new model would be loaded, guys, and this is the name, new model. Okay, now let's upload a test image. So in the testing folder, I'll first of all upload a daisy image. So let's say I will upload this image here. Now let's rename it. Rename file. I'll name it as daisy.jpg. Daisy.jpg. So let's define the path, image path is equal to daisy.jpg. Okay, so first of all, guys, what I have to do, I have to load this image. And how to load? I think, remember, we imported a image functionality here from PIL. So with the help of PIL I can load the image, and this will give you the metrics, image metrics. See, this will give you the image metrics, but it's not visible because you are running in the Colab. That's why it is directly showing you the image. Okay, so first of all you have to do the transformation, the same transformation you did where in the validation. Now see, one thing I forget to tell you, in the validation image, here we are not doing any kinds of augmentation technique. We are only doing the resize operation. Okay, because what we are doing, guys, we have to do the resize operation at the end. Because if you see resonate 18 input size, it will take 224 3. Okay, this is the image dimension. So here I think they have mentioned, see, 224 comma 3. I can open the Keras application. There I think they also mentioned this. Resonate 18 is not available in Keras application. Okay. What do we see? All the Resonate model takes 224 comma 3. See, 224 comma 3. Okay. So that's why we have to do the resize operation. Okay, we're doing the resize operation. You can see 224. And here we're not doing any kinds of flipping operation or any kinds of augmentation operation, because this is the validation data. Augmentation can be only applied on the training data, okay, not any other data. That means whatever we did in the validation, the same thing we have to do for the testing data as well. Okay, so let's try to define the transform function here. That means the processing function. So this is the processing function. Here you can see we're resizing, we're doing the center crop operation, we are converting to the tensor, and we're also doing the normalization. Okay, now we'll try to apply the process function on my image. Once it is done, we'll also add the batch dimension, guys. I think remember we also need to add the batch dimension. So let's add the batch dimension. Okay, now this is the input batch you got. Okay, this is the input tensor you got, and if you see the shape, this is the shape. So one means this is the batch dimension, 3 channel 224 comma image. Okay, that means with this 224, height is also 224. Yeah. So once my image input data is ready, now I can do the classification. Okay, so to do the classification, you can execute this code. Let me show you. This is the code. First of all, you are making the torch as no grad. No grad means now it will not upgrade any kinds of weight. Okay, no, it will not update any kinds of gradient. That's why no grad. Okay, it will only do the inference operation. Now model, you are giving the input data and it will give you the output. Okay, now from here we are taking the max. Okay, maximum predicted class. Okay, I think remember what is maximum predicted class, guys. The softmax activation function, I think remember. Okay, now we are having the classes name. Now this will give you the maximum, that means the ID. Okay, ID. Now if it is giving you the 0, that means which particular category it will detect, guys. Which particular category it will try to classify. Definitely Daisy. And if this predicted class is equal to 1, that means it's a dandelion. Okay, now let me see. Now see, it is giving Daisy because it has predicted 0. Okay, if you see this predicted item, print predicted item, it's 0. Okay, that's why it's Daisy. Okay, now if you want to visualize this visualization, you can use this code. So here we're using this matplotlib to visualize the image as well as the classification on my image. See, predicted Daisy image. Now let's try to pass one dandelion as well. So I'll upload flower classification, testing dandelion. So let's upload one of the dandelion image. So let's rename it dandelion.jpg. I'll copy the path and here let's try to specify. I'll execute all the code. Now see, guys, it will predict as dandelion. Okay. Now see, there is no overfit condition because we are having huge amount of training data. See, like you can use sigmoid activation function or softmax activation function. Both will work, Thomas. Okay. You can also use sigmoid activation function. It's completely fine. Sigmoid will give you the only one threshold value. Okay, 0 to 1 threshold value, but sigmoid softmax will give you two let's say probability value. So whichever will have the more probability, that class would be considered as my predicted class. How can we use the VEET model for object detection, classification, and models are the best? Jatin will try to discuss going forward. What are the benefits of giving 1000 neurons and 700 to do? Yes, you have to do, first of all, you have to give the original model output size. Okay, original model output size. Then you have to give your own model output size. Okay, this thing you have to do, okay, in the PyTorch. Hmm. So yes, this is the entire image classification demo with the help of PyTorch. I know for the beginner it would be a little bit complex to understand, but at the end, if you like learn the PyTorch, it would be easy for you. Okay, so no need to worry. I will come up with a PyTorch series on my channel, so you'll be able to understand. Now I'll suggest for the beginner guys, those who are starting with image classification very first time, you can go ahead with the Keras and TensorFlow, and those who wants to export the advanced one, you can use the PyTorch as well. Okay, it's up to you. Now next class onward guys, I'm going to start the object detection uh, concept. First of all, we'll try to understand the theory of object detection. Then I'm also going to discuss the practical of object detection with all the library, all the model we are having. And resources I'm going to share in the same link guys. I think you know that we are having a GitHub link. So this is the GitHub link, and here day wise I have updated all the material. You can check it out. Which library use the most for the researcher? Those who wants to customize, they are going with the PyTorch, and those who only focus on the development, they will be going with the TensorFlow Keras. Okay, both library are good at the end. Got it? Okay, so any question guys, let me know. Any question if you have, you can ask me. Otherwise I think I can conclude the session for today. For me, I like PyTorch. Okay, I like PyTorch because uh, I'm more interested in research and the self exploration. Okay, I do like multiple experiment always. That's why I love PyTorch. How can you increase facial attributes classification performance? See, we're not talking about the facial attribute classification performance as of now. Thomas, whenever I'll be working with the facial model, that means the face embedding model, that time I'll try to discuss this part. Okay. And if you want to get the information about it, you can personally connect me over my LinkedIn, or I think you remember, I also have a group, Telegram group. There you can connect me. Okay, guys. So now you can try, but when you need the model in TF Lite TensorFlow. So TF Lite, it is for the like edge devices. If you want to, let's say, quantize the model, and if you want to deploy it over the edge devices, that time you need the TF Lite. Even we can also convert the PyTorch model to TensorFlow. Okay, even TensorFlow model to PyTorch with the help of Onyx. Have you heard of this name, guys? Onyx. Onyx runtime. Okay, with the help of that, we can do it. I'll take a session, guys, on top of that. Okay, how to use the Onyx to convert any kinds of model to any kinds of let's say format. Okay, I'll show you this part. Yep. So yes guys, this is all about from today's session. I think you got it, how we can do the image classification with the help of PyTorch. And now next, let's start the object detection, and definitely we'll be enjoying a lot. So thank you guys, bye everyone, and always remember, consistency is the key. And if you're new to my channel guys, please try to subscribe. Let's hit 50k subscriber as soon as possible, and also give the like in my video. Thank you guys, bye everyone, good night. And resources, just try to find my GitHub. Okay guys, thank you, bye.